Hello everyone. In this video, I am going to explain Verilog data types. Before you watch this lecture, go and watch lecture 1, Introduction to Verilog. Before we discuss about data types, let's discuss about various data values available in Verilog. There are 4 data values which are available in Verilog which any variable can have. The 4 values are 0, 1, x and z. 0 represents logic 0 state, 1 represents logic 1 state, x represents unknown logic which is either 0 or 1, and z represents high impedance state. Now we will discuss about data types. Different data types available in Verilog are net data type and res data type. Firstly, we will discuss about net data type. Net data type, the variables which have to be continuously driven has to be declared as data type net. These data types can't store any value. For example, in this AND gate, A and B are inputs and C is output. C is continuously driven, and whenever A and B changes, C has to change, and C can't store any value. So this C must be declared as net. And the default value of a net is high impedance state Z. There are a different type of net data types. Some of them are wire, war, WAND, try, supply 0 and supply 1. As discussed, in this AND gate, C has to be declared as wire as it is continuously driven by A and B. So C must be declared as wire. Generally, wire and try are both are similar data types which shorts the inputs. Here, generally this try is used to declare the output of tri-state buffers. Here, output is same as input only when enable is high. When enable is 0, output is high impedance state. So this type of variable output of tri-state buffer has to be declared as try. And WAND, here in this diagram, A and B both are controlling Y. For example, if we assign Y is equals to A and in the next statement we assign Y is equals to B, this the tool can't decide whether to take A or B. For example, A is 1 and B is 0. The tool can't decide the value of Y, either it is 0 or 1. So when we declare Y as WAND, Y does the operation of AND here and assign it to Y. This WAND does the operation of AND here and assign it to Y. Whereas WAR does the operation of OR here and assign it to Y. At this junction, when we declare it as WAND, it will do operation and if we declare it as WAR, it will do operation WAR OR and assign it to Y. For this purpose, we use WAND and WAR. The other data types are supply 0 and supply 1, which are generally used to represent ground and VDD of the circuit respectively. Supply 0 represents ground and supply 1 represents VDD. The next one is a register data type. As I said, net data type can't store any value and it is driven continuously. Here, register data type can hold a value or retain a value that is assigned to it. So it is often used for storage elements like sequential circuits. Under register data types, there are many data types: reg, integer, real, time, which we discuss in the further slides. The default value of reg data type is X, whereas for net data type, it is high impedance state, as I said before. Yeah, integer data type under reg data type, the default size is 32 bits. Integer, it is declared as, for example, integer C. Default size is 32, but based on the assignment done to this variable, it can modify its size. For example, we declare integer c and we assign c is equals to a plus b, whereas a and b size is 16 bits. So this c size becomes 17 bits, whereas 16 bits for sum and 1 bit for carry. So it can modify the size based on the assignment done, but default size is 32 bits. And the next data type is real data type, which is used to store floating point numbers. For example, pi 3.14, we have to declare that variable as real real x, where we can assign x is equals to pi or some rational number in the further code. So um, real is used to represent floating point numbers. When we assign x a variable x as pi, but we declare it as integer, then it will round off to the nearest number and assign it to x. For example, pi is 3.14. When we declare x as integer, then it will round off to nearest integer 3 and assign it to x. Then x is equals to 3. Whenever we declare x as real x, then x value will be 3.14 as it is. And the next one is time data type. Time data type is generally used to represent simulation time. Here in the example I mentioned, time sim underscore time is a variable which is representing the simulation time. Here under the initial block, um, I'll explain about these blocks in the future lectures. Now consider this initial block as a block of statements. In this initial block, in a statement, in one of the statement, this variable sim underscore time is assigned as $time. This $time function generally gives simulation time of that circuit. So to represent to assign simulation time, that variable must be declared as time data type. This data type is generally used in only in simulation, not in synthesis. So as we discussed here, everywhere as we discussed, we declare these variables as single bit when we don't mention any numbers here, like I'm going to explain here. For example, while a, we did not mention any size here, so a default width of a is single bit. If we want to represent multiple bit width variables, we represent them as vectors. Where example here is while 4 down to 0 a, the left side bit left side bit represents the range represents the MSB of the bit width, and right side um, right side number denotes the LSB of the bit width. So here range 1 and down to range 2. Range 1 represents MSB and range 2 represents LSB. For example, we denote 0 down to 4A, then this MSB denotes the 0th bit of A, whereas LSB denotes 4th bit of A. So don't get confused here. So range 1 represents MSB and range 2 represents LSB. Be careful while declaring the vectors uh, while declaring the vectors. So, and the part of these vectors can be used in any expression. For example, here we are declaring b as y, which is of 2-bit width. We are b is equals to we are assigning b is equals to 3 down to 2 of a. So these 2 bits can be assigned to b. So the part of the vector can be assigned to other variables. And next one is parameters. Parameters are generally used to represent constants. For example, there is a 32-bit width constant, 32-bit constant, which has to be used in code many times. If we mention a bit wrongly, the whole code will not function correctly. So whenever we want to use repeatedly some constants, we use parameter. Here we are representing parameter x is equals to 51. Wherever we want to mention 51 in our code, we can use x in that place. The default size is 32 bits and it can be modified based on the assignment we done to that parameter. For example, we assign 4-bit binary number to x, then it will become 4-bit size. And the constants. The representation of the constants in the code must be like this: size, tick, base and number. Size represents the size of the bits and base represents the base, either it is binary or hexadecimal or decimal or octal, and the number. Here example says 5-bit binary number 01010. So in this way we represent constants in Verilog. This is the end of the video. In the next video, I'll explain about the various operators used in Verilog. Thank you.